Is it correct for you?
We can see both the, it's not in full screen.
Oh, okay. Sorry, because I have some trouble. Is it better like this?
Yes.
Okay, but I cannot see you anymore. What happens? It's very strange. So I stop just a moment with some difficulties. So I introduce myself first. If you have any problem, please say a few words. So I stop the presentation because I cannot see the window with the students right now because I have a very small screen. But I introduce myself. So, you know, I am Jean-Paul de Rouen from the University of Reims. The official name of the university is Reims Champagne-Ardenne. It's a region in the northeast of France. And I am working with the geological research group. And my main topics of activities are remote sensing, geological mapping. Oh, sorry, there is a problem with the screen. One more. Remote sensing, but first I'm a geologist, so I work with remote sensing and for geological mapping, for also mapping related to geological hazards and particularly along the coastal areas. And I worked, for example, in some places in France, but also in Vietnam and also in Africa. From education point of view, I deliver lectures in geosciences, in field geology, field work, remote sensing, GIS, geological mapping, and also geological hazards. And also, as you can see here, this is a talk in the field with some students in the vineyards of Champagne. And I teach geology for the Diplôme National d'Œnologue. It's a national diploma. It's more or less the same than a master degree. And it's dedicated to œnology. This is the science of the wine. And I know that in Vietnam, there is some vineyards in the Dalat area.
Excuse me, Professor.
Yeah.
We don't see your screen yet. We don't see your screen.
Ah, okay. It's the same for all students?
Yes.
Ah, okay. So there is also a trouble for me. Do you see the camera?
Yes, it's clear.
Okay. I don't understand what happened. It's very strange because this is the reason why I stopped for a while because I cannot see you and I like to have the small window okay, maybe I have to do like this. Okay, I continue.
Good.
So just, sorry, there is a question?
No.
Please switch off your microphone when you heard me. So this is just a small map of France to show you the location of Reims. You know, Reims is not very far from Paris, the capital city. It's about only 150 kilometers to the northeast. And we are not very far from Belgium and Luxembourg and Germany. And so you can see France with a lot of seas, the Channel, Atlantic Ocean, Mediterranean seas. This is the reason why coastal issues are very interesting to study, and particularly using remote sensing techniques. So a few words about my background. So I defended a thesis a long time ago. It was in November 30 years ago in Paris, and it was a work on geology and tectonics, but using the first SPOT-1 satellite images from the end of the 1980s, and with application in some regions of South France, the so-called Cévennes and Languedoc areas. And after my thesis, I worked with the French Geological Survey as a geologist, an engineer geologist, about 11.5 years. And here, for example, you can see my last job in Normandy was, I was in charge of the French survey in Normandy. And especially, I was in charge of the geological mapping program. And here, this is a view taken during the winter, because the fieldwork is very nice during the winter. There is no more vegetation in these areas. This terrain here is made of clay. These are Callovians, Jurassic clays. And after working with the French survey, I went to the university. But I teach previously a number of times, especially with the University of Orléans, and also abroad with formations in Haiti, in Morocco, or in Bolivia, for example. So in 1999, I became a professor at the University of Bordeaux. You know, Bordeaux is in the southwest part of France, not very far from Toulouse, at about 220 kilometers far from Toulouse. And I worked with Institut Egide. It is an institute dedicated to geology and environmental sciences. And in 2008, I went from Bordeaux to Reims. You see, this is a Reims campus. And just a few words about the different steps in Reims. I was the dean of the Faculty of Science, but this is important because this is the reason why I am involved also in the Master of USTH, because during that period I participate with the president. You know, here this is the president of the university, and also with the vice president dealing with foreign affairs and with education. We launch a number of educational programs, and particularly with USTH. This was during a graduation ceremony some years ago with the mayor of Reims, Madame Adeline Hazan here. And after that period, just to indicate my some steps of my career, I was a member of what we call the Conseil National des Universités. This is a council dealing with the career of the teachers in France, you know, the professors and assistant professor. And I became the president of this council during 4 years, you know, from 2015 and 2019. And this photograph was taken in Sorbonne University. You know, this is very famous. This is the court of the university with the member of the assembly, all that people representing all the disciplines, law, right, political science, economics, and also literature. And you have social sciences, history, geography, and all the science as well, engineering, earth sciences, informatics, and also educational science. So, you know, all the members representing the different sections, what we call sections of the council. This was very interesting, but very time consuming because it was necessary to work with the minister and especially with the different directions of the minister. And now in France, it's relatively hard to work with the ministry. So more interesting probably is about education because I am also in charge of a master in Reims. I planned and organized a new master. It is the first master in geoscience in Reims, and the name is Geosciences and Hazards. And I launched this master in 2012, so 8 years ago. In the past, I also was a co-member of another master degree in Gabon. You know, Gabon is a place in Equatorial Africa, and the name was Techniques and Methods for Monitoring Environmental Informations. Unfortunately, this master degree lasted only a few years, but it was very interesting, and I was in charge of remote sensing, and particularly for optical remote sensing. And as I mentioned previously, I organized also courses in Morocco, in Haiti, in Bolivia, and in other countries in Africa, such as Ethiopia, Senegal, or Ivory Coast. So I'm very interested in the educational program with all countries around the world because every country encounters its own issues relatively to the environment. So it's very interesting to develop remote sensing in the different climates and morphological settings. And also in the frame of the thesis of the PhD program of Vietnam, I was also the director of Son thesis, you know, probably Son Tong-si, and Son defended his thesis in 2016, and the title was Mapping Tidal Flats in Vietnam using remote sensing techniques. With Son, we proposed a continuation of these topics, but I have no news, no information about the possibility to have a new thesis in Vietnam in that about that topic. So as I mentioned also previously, in December 2013, with the vice president, this guy was a vice president of the university in dealing with foreign affairs, and we met some people from USTH. Here, you probably recognize some guys, and at that time, the University of Reims was only associated to the master degrees for nanotechnology. You know, there is a nanotechnology master, and this was the first involvement of Reims, and associated Reims to the WEO master with lectures in remote sensing, but also another colleagues from chemistry intervenes in the first year. Probably you had Professor Emmanuel Guillon last year. And also, I am very interested in the space activities. So we decided to make the modules, the WP52 module, as a common modules of two different masters. And I think it's a very good thing. And also, I know that Son was admitted as a member of the staff of USTH, but not in the WEO department, but in the space department. So it's good like this. So this is just a field view of the work with Son in the Red River estuary. We work very hard in the tidal flats, and especially in the fine sands and clays. And we make very interesting observations and on work. It was very nice. So, and also I'm interested by a lot of the activities of the LMI Lotus laboratory. You know, this is the lab where the WEO department is involved, and I know Sylvain Houillon for a long time, before the Vietnam, and I think that it is very interesting to develop a common project in the future. So just I stopped the presentation just for a while because I would like to have a look, because it's difficult to, I don't understand why I cannot see you. It's very strange. So, are you still connected? It's okay?
Of course, there's no problem.
Okay. Okay, I have a problem because I cannot see you. I don't know where is the where is the camera? No, not the camera, but so I don't understand what happened. Maybe I have to stop. Okay, it's okay. I stopped to share the screen. I think that you can see only me. When I share the screen, can you some drills and exercise, not only theory and background? Okay, so okay, I think that I will discuss after about also the organization of the week, because you know that formerly I spent 3 or 2 hours in the morning in Hanoi with theory, and the afternoon was dedicated to the practicals. So I will try to do more or less the same. And probably I will give you some times at the end of the day for you for working on some drills, and we can correct after during the next session. Okay. So, but I have some points to establish before. So I share again. Where is I share? I hope it's correct for you. So my course is mainly dedicated to the generalities and some general information about remote sensing, but also on the recent developments of remote sensing. And I will particularly illustrate in the scope of what we called integrated river basin management, coastal survey, because I know that there are some students interested by the WEO master, but I think that this year it's only the news option and not the HO option open. And also for the space students, if you have particular areas of interest, do not hesitate to indicate what are these points of interest. And I will illustrate with a lot of case studies based on data such as Sentinel-2 or Sentinel-1 data, but also archive data, for example, Landsat imagery, and also radar imagery such as ERS-1 or ESA and so on. And what is very important is a combined study, is the interest of the combined study of satellite data with other data, because it's interesting to analyze remote sensing images, but it's also necessary to have some goals and not analyzing the image as a whole, but also with one specific target in mind. Okay. Unfortunately, it will be very difficult, I think, that to speak about specifically GIS here, because it will be difficult to do only a GIS exercise, but we can discuss about that topic as well. So these are, you know, the main information about the week. This was a former organization, and this is a current organization. So, as agreed with the staff of the masters, I will organize the examination. You know, there is an exam planned in the frame of this lecture. So I think it's better to do this examination at the end of the week, and we will organize. I think it's 2 hours for the examination, so we can organize the examination at that time. And also, I have to evaluate the practical part of your work. So I will evaluate your some exercise about remote sensing. And note also that all presentations will be sent to you after the lecture. I will send you the corresponding images and the corresponding curves. Just a minute, because I have always the same problem. I cannot see the videos of the students, so I do not, because he proposed to me to mask the video, but I cannot see the video, so it's very strange. So it's not, never mind, I continue. So the course is organized in great chapters. So after preliminary purposes, you will have some information about an introduction and the basic aspects of remote sensing, and progressively we will go further in detail to have a look at the more recent progress in remote sensing imagery. So basically, we can say that remote sensing, this is the observation from the space in different wavelengths. And this wavelength are all the wavelength, possible wavelength in the electromagnetic field. After, I will show you the interest of the different ranges of the electromagnetic spectrum. But it's clear that some ranges are more interesting. I speak about the visible and infrared range, and also the hyperfrequency range are more interesting for remote sensing than others. But you have to have in mind that this is a physical method, so it's necessary to always relate the information in terms of reflecting signal or backscattering, and to convert in physical properties of the soil, such as moisture, such as roughness, or pigment content, for example. So basically, remote sensing can be applied to any target, to any topic, such as land cover, urbanism, cartography as a whole, vegetation, geology, glaciology, if any, if you have some ice in your mountains, natural hazards, but also meteorology and the other planets. But I will come back later to the definition I give to the to remote sensing. So I like to begin with some illustrations of the use of remote sensing using some recent, or not necessarily recent data, but some spectacular illustration of remote sensing. So unfortunately, at the Earth's surface, we have a lot of hurricane, or a lot of troubles and issues due to high winds in the different parts of the world, in the Pacific or in the Atlantic Ocean. And last year, Hurricane Dorian devastated a large area in the Caribbean Sea. You can see here the Florida boundary, and Bahamas and Cuba Island here. And you can see a very large phenomenon, such as the hurricane, because here the size of the image is about 1,500 kilometers from west to east, and about 1,000 kilometers from north to south. So it's a very large scale image get by Moody's sensor with a relatively coarse space resolution, but very interesting to look at the particular shape of this kind. You see this kind of winds. So another illustration, very famous in France, because maybe you know that France has some very small islands in the Caribbean Sea, in the Antilles, and especially Saint-Barthélemy and Saint-Martin. You see, these are these very small islands far from to the east of Puerto Rico, and after you have Cuba as well. And here you can see the two islands in the what we call the Lesser Antilles. This is Lesser Antilles, and this is the main Antilles with Puerto Rico, Haiti, and Cuba, and Jamaica as well. And this is the first image, the September 6th. You know, with the center of the hurricane just in the area of the island, and the islands were totally devastated. And after the pass of the hurricane, this was Hurricane Irma in this case, it was 3 years ago. More recently, in August 2020, you know, in the Beirut harbor, a very important blast occurred. And here you can see the location of the blast using a relatively high resolution satellite. This is Sentinel-2, and this is just before the explosion, and this is after. So you can see some devastation, but it's not very easy to map because the ground resolution here is only 10 meters. So you can use more interesting data, such as the best data you can get currently. These are the WorldView 2 data with a ground space resolution of about 50 centimeters. So here, this is the same area, the harbor of Beirut, the capital city of Lebanon, along the Mediterranean Sea coast. And you can see here the effect of the blast with the destruction of a lot of buildings. And also you have some boats devastated. Okay, and this was the location of the main explosion, you know, due to ammonium nitrates explosion with a large amount of this product. And when this product is in connection with water, you have a very large explosion. In 2020, also occurred a lot of fires, especially this picture was taken in January. So we are in the southern hemisphere here in Australia, and particularly in the southeast part of Australia. You can see in that region a lot of fires. Here with this large scale data, we can only see the plumes of the smoke, but this is an enlargement. Okay, this is Tasmania Island, and this area is a more inhabited areas of Australia, with the city of Sydney and Canberra and Melbourne, and this is a Victoria province. And in that image, you can see all the red spots correspond to one fire. So it was very, very important because it devastated the forest itself, but you know that smoke can induce also a lot of health problem and also pollution. Okay, this is an illustration of the fires in Australia, but unfortunately, there are a lot of other places with forest fires, such as the Amazonia. This is a picture representing a map of the Amazonian forest. And in green, these are the remaining forests, but in yellow, you have the place deforested, and the active fires in August 2019 are represented. You can see that they are frequently related to the road penetrating into the forest, because most of these fires are anthropic in nature and not the natural fires to gain some crop areas, especially from palm tree crop. So, and it is mainly the area close to the boundary with Bolivia here. This is Bolivia. I will speak about Bolivia sometimes because I worked in Bolivia, not in the Amazonian area, but in the mountains. But the Amazonian area of Bolivia is the same than the Amazonian area of Brazil. So you have a lot of fires in Bolivia as well, in the very flat areas of Bolivia. These are some detail. Here you can see some smoke area. You see the deforestation is still active. And you are here in the area close to the border with Bolivia. The name is State of Rondônia. And this is, you know, the fires are just emphasized, highlighted by the red pixels. So it's possible using the electromagnetic spectrum to find some ranges corresponding to the temperature of the fires. But here, this is not the thermal infrared range used, but the shortwave infrared range at about 2.4 micrometers. I will speak about that properties in the generalities about electromagnetic spectrum and remote sensing. So another view, but this time it's the corresponding US satellites to MODIS. The previous one, this was MODIS here, okay, and acquisition is during the day, in the morning, here because it's Terra. But here it's another, it's a Suomi, the name is Suomi, and this is a night acquisition, and this time the spots are represented by thermal infrared, but only here in this time. And you see, it's more difficult to get good data during the night and in the thermal infrared range because the energy is very low. And so detecting such a low signal is difficult. So there are a lot of noise related to the capture. Other views more accurate. Recent views from a volcanic eruption. This is Volcan Ubinas in Peru. This is the most active volcano in Peru, in the Andes. And in July 2019, a very large eruption occurred. And you can see here, using a Russian remote sensing data get by resource P, it is in the optical range. This is natural color. And you can see the craters and the magmatic chamber is just here, and a lot of smoke going here to the southeast of the area. And this is a field view of the eruption. And a more recent application of remote sensing, maybe you know, in France and also in Italy, in southeast France and Italy, just along the border, very tragic flash flooding occurred in October, just 2 months ago, and a very large amount of rain fall on the Alps, on the Southern Alps, and there are a lot of flash flooding because, you know, here in the Mediterranean region, there are a lot of runoff and a very few infiltration. So the bedrock is usually dry, so the runoff is very important. And a few hours after the rainfall, you can see here the plume of the different rivers as the Var River. The Var is the river close to Nice city, and also the Roya River here. The mouth is in Italy, but the watershed is shared between France and Italy, and some areas were destroyed. And the French Geographic Institute carried out just 2 days after, or 3 days after the event, carried out aerial photograph campaign. So I can illustrate the effect of this flash flooding. These are aerial photographs with 25 centimeter of resolution. This small village is Saint-Martin-Vésubie here along the Tinée. The river is the Tinée. You see here, this was a photograph taken during August, just 2 or 3 months before the event. And it's not clear where is the river, because we can see only some trees along the small valley here, the ridge indicating a valley and the city. But here you see, after the tragic event, the devastation of all the area and all houses built along the valley, and especially in very dangerous areas, in what we call the major bed of the river. So you can see also very large boulders here, and no more trees. All the trees were destroyed in that case. Another example, very dramatic example, here in Roquebillière. It's a small area also further to the south, related to Saint-Martin-Vésubie. And here you see the Tinée Valley is larger, and all the area has been destroyed, and only you can recognize some houses here. And this is an electric power plant, totally destroyed, and all the trees were also destroyed. And just I go back here, you can see, if you enlarge the Sentinel-2 data, you can see at the edge of the plume, in a natural color, a reddish or brownish color corresponding to all the trunks, all the timbers of the trees concentrated in the sea, in the Mediterranean Sea. So this is very clear. And also a last example, here you have a road, not close to the village of Marie, in the Tinée River as well. And here you see the river has totally destroyed the road in that area. So even here some landslide probably. So it's clear that remote sensing is very interesting to survey the effect of tragic events and to compare between the former setting and the setting after the event, and if possible, very close to the event itself, because sometimes it's difficult to see the effect maybe 1 or 2 years after, because roads were repaired and built, bridge rebuilt, and so on. Okay, and I would like to stop with, I think, one of the most a spectacular illustration of remote sensing, and it concerns Vietnam, and particularly here, this is a view of South Vietnam, because this is the Mekong River, the east of the Mekong River. And this is not a recent satellite data, because it was acquired the 1st of January 1973, just a few years after the major bombing of the US Army. And you can see the effects of the Agent Orange. It's very clear, the path of the plane and the destruction of the forest. So a few years after the event, you have some forests remaining, but it was necessary to wait for a long time. And I know that these events were of very, very tragic consequences for Vietnam. Okay, this was the introduction to my lecture. I stop just a while. Where are you? I stopped. Okay. Do you have? I continue right now. And the chapters, the following chapter is, the title is A Brief Introduction to the Interest of Remote Sensing. So, about space techniques, it is important to know that our brain and our eye as a captor are well adapted to the 3D view. So very early, human beings drawn, imagine the cities and landscape as seen from the sky. Even, for example, in this case, this is a picture of the city of Reims in the 17th century, but around Reims you have no mountains. It's only small hills and plateau. And here, even at that time, without any plane and satellites, it was imaging the shape and the image of the city with the cathedral here and Saint-Rémy Church, very famous, also in Reims. At that time, with a wall around the city and the small river. This is the Vesle River here. So it is very important because the eye of the human beings is adapted to the 3D and also to the perception of a lot of different colors. This is very important for remote sensing. Remote sensing deals with any information acquired on board a vector. That is the name, general name for example, the satellite, a probe, an aircraft, a drone, or a kite. And what is important is to have some sensors on board, at least one sensor for the record. Here, this is an example of an image acquired on a relatively strange natural object. This is comet Chury, as seen by the Rosetta probe. Rosetta is a probe from the European Space Agency. And in 2014, the probe met the comet. And the official name of this comet is Churyumov-Gerasimenko. These are the two Russian scientists who discovered the comet about 1 century ago. And the radius of this comet is about 2 kilometers, the radius. The shape is very strange. It looks like peanuts, something like that. What are the main advantages of satellite images? The first main advantage is what we call specialization. This is the capability of the image to generalize the information for a very large areas. And this is an example of a very famous area in France. This is the Mont Saint-Michel Bay. And this is a very beautiful view of the bay, get by the Japanese ALOS Avenir 2 sensor with a space resolution of 15 meters. It's comparable to the sensor of Sentinel-2 right now. And it's possible using the data chronicles to get the best data relatively to the low tide. Because if you are working on the sediments in the bay, and this is very interesting, you have to choose the best setting. This is the best relation between the low tide and the path of the satellite. I will discuss this very important point later. Sorry. And this is, for example, the geological map, and I participated to the geological map of this area because the Mont Saint-Michel here is in Normandy region, and you have a lot of different kind of sediments, from the coarse sands to the very fine clays, and different kind of sediments and also vegetation. And the map was published in 1999, and at that time we use a spot data as a reference, because you know, in tidal areas, in tidal flat areas, landscape are very changing, and also it's necessary to use one setting, for example, for the main river channels, because you have changes of these curses due to the intensity of the tide, but also to the flow of the rivers. And also it depends from the season, because you have, for example, in the channel, this is the sea here, between France and England, you have a very important high wind period during autumn and winter time. So you have different changes occurring at that time, and in summer it's more quiet, but you have more vegetation. And vegetation is very interesting for fixing the sediments and for contributing to the sedimentation, particularly of the very fine particles. Well, here it's a very nice plume, and these very strange features are due to fisheries. You know, this is for fishing. You have the nets of the fishers here in the sea. So specialization is very, very important. And here, this is an example of specialization using radar data. We are in Gabon. This is a map of Gabon, very not very close from the equator, because Gabon is crossed by the equator. So Libreville, the capital city, is to the north of the equator, but the southern part of Gabon, here is the equator, is in the southern hemisphere. And this is a very large river, so-called Ogowe River. And this is also an ALOS image, but in this case, it's a radar, the so-called pulsar sensor, and the very large mode of the sensor, of the radar sensor, with a width here of about 300 kilometers. So Gabon is not a very, very large country. So you have, with this only this scene, you have about 1/5 of the country. And it's very clear, you have mainly the 3 types of backscattering. You have the black response corresponding to water. Here, this is the Atlantic Ocean, and this is the Ogowe River, and you have a lot of lakes. Okay, and you have also the green, no, sorry, not the green, the gray color. The gray color corresponds to vegetation because it's rainforest areas, such as in a lot of parts of Vietnam, particularly in the north. So you have rainfall forests, relatively homogeneous. So it's provided a gray backscattering, that is to say an intermediate backscattering value between black and white. And the white areas are the more backscattering areas. And you see that these white spots are along the Ogowe River. And it is due to the fact that this area is more humid, and the white is due to moisture of the areas around the Ogowe River, with some places with crop areas, but not everywhere, because you know, it's swampy and marshy area. So you can discriminate between 3 main types of backscattering: the black, the white, and the gray. So this is interesting because you know also that radar is independent from the cloud cover, and in equatorial Africa, such as in all the equatorial areas in the world, you have always a lot of clouds, and it's very hard to get the image with an optical sensor and cloud-free image with an optical sensor. So radar is better, and but it's more difficult to interpret. So we will discuss the radar interpretation during the practicals. Okay, this is a nice view of Gabon. The second, after specialization, the second main advantage of properties of remote sensing data, of satellite images, is the temporality. This is the capability of remote sensing to provide repeated acquisitions and possibly planned acquisition, if you know when one event will occur. And this is unfortunately a very well-known example corresponding to the Aral Sea. You know, the Aral Sea is now located between Kazakhstan and Azerbaijan in Central Asia. But this area was formerly in the USSR, and during the 20th century, the area was dedicated to some crops, and these crops were used a lot of water, such as the cotton, and you know that the Aral Sea here, about 20 years ago, was separated in 2 major seas. But since 2000 onward, you can see that the remaining sea is progressively disappearing. Here you have some, we are in about 2006. We can see that the main sea remain is totally dry and is converted in what we call in geology evaporites, that is to say some salt and gypsum minerals. And it was possible after this very dry period to get some water here. But you see, it's a very dramatic setting. It is due to the fact that you have two major rivers, the Amu Darya and Sir Darya, coming from Central Asia, and the water of these rivers were used to irrigate the crops, and unfortunately not feeding, no more feeding the lake, and the lake now is in a very dramatic setting. Okay, this is large-scale data from Moody's, but it's possible to use more accurate data on that kind of issue, and especially the Landsat series. It's more interesting, and the longer existing series, because Landsat, the first Landsat was launched in 1972, and these are views from Landsat 4 and Landsat 8. So it's possible to have a look at the area. You know, this is exactly the same place in 1989 and in 2014. So you see that the water has totally vanished here. It was the main lake here to the east. So it has totally disappeared. Only this small area is remaining with some waters, and the waters are very salty. So it's not possible to have any life in this water. No more fish, no more other organisms. But it's interesting if you are dealing with evaporite, and I am interested in evaporite studies. And I worked, for example, in Tunisia with another PhD student working in the field and also using remote sensing data. And remote sensing data are interesting, particularly to discriminate between salt and gypsum. Salt is a halite, you know, the chloride. And it's very difficult in the visible range to distinguish between halite and gypsum, because the response is very high in both cases. So we have very white areas, but gypsum has a very low response reflectance in the shortwave infrared. So whereas halite has always a very high response. So it's possible using middle and shortwave infrared ranges to emphasize gypsum mineralization. If you know chemistry, you know also that the different products cannot crystallize at the same time, because it depends from their own properties. So you have a graduation from different kind of mineralizations of minerals, such as potassic minerals, and also gypsum. This is sulfates, and so on. Okay. We use data from the electromagnetic spectrum, and mainly we will use the center of the spectrum dealing with the visible range, but the visible range is very narrow. We will look further in detail this area.